Hello and welcome to Number Theory for Everyone, the show in which I take something that I've learned about in my study of number theory and present it in a way that I hope is accessible, fun, and possibly even useful. I'm your host Tony, and you're watching the channel Tony Talks About Math. On this episode of Number Theory for Everyone, I'd like to talk with you about fractions. So let's start by throwing a couple of fractions on the screen. Here's 2/3, that's a good fraction, and another one is 3/4. Now, a basic question that we could ask about these fractions is, which one is bigger? I think you'll agree with me that 2/3 is the smaller fraction and 3/4 is the bigger one. A slightly more interesting question that we could ask is, can we name a fraction in between the two, something that's bigger than 2/3 but smaller than 3/4? If so, what are its numerator and denominator? Now, there are lots of possible fractions that would fit the bill here, and one approach might be to say, let's take the average of 2/3 and 3/4. However, what I want to show you today is something that is much more straightforward to calculate than the average. It's also more flexible, and I think it has a really nice tie-in to a very concrete way of thinking about these fractions. And this is the idea of the mediant of two fractions. This is not to be confused with the median of a set of numbers. That's an idea out of descriptive statistics. We're talking about a mediant. So what does that mean? Well, to find the mediant of two fractions, rather than just handing you a formula, I'm going to give you a scenario that makes this a bit real. Suppose we're throwing darts at a dartboard. And in our first round, we have 3 darts to throw. And we have 2 bullseyes, and the third one is a miss. So we got 2 out of 3 on the first round. Now in the second round, we get 4 darts to throw at the board. And we have 3 perfect hits and 1 miss. So our performance on round 2 was 3 out of 4. So in round 2, we did a bit better than we did in round 1 because 3/4 is more than 2/3. Our overall performance is in between the two because it's better than 2/3 because we improved on the second round, but it's not as high as 3/4 because we didn't do as good on the first round. What is the overall performance? Well, our total number of hits was 2 plus 3, and our total number of attempts was 3 plus 4. So that's 5 out of 7 for our overall success rate. 5/7 is bigger than 2/3 and smaller than 3/4. It is the mediant of those two fractions. Now, before I say much more about what the mediant is, I should say a little bit about what it is not. When we do this operation of adding the 2 numerators and adding the 2 denominators, one thing that we're certainly not doing is adding the 2 fractions. This might be how you imagine fraction addition works if you're not sure how fractions work, but this is not fraction addition. If we were to add 2/3 and 3/4, we would certainly get a number bigger than 1 and not something in between these two. If we were to take the average of these 2 fractions, we would get something in between, but this is not the usual average of 2 numbers. It is a kind of average, and we'll have more to say about that very soon, but first, I'll say one more thing that the mediant is not, and this is perhaps the most surprising. The mediant is not an operation on 2 numbers. It is an operation on two fractions, which is not quite the same thing. The reason it's not quite the same is that the result depends on how we write the fractions that we're starting with. Let me show you what I mean. If we take the second fraction here, 3/4, and multiply the numerator and denominator by 2, then we're going to get 6/8, which is the same number as 3/4. However, if we calculate the mediant now, we get 2 plus 6 on top and 3 plus 8 on bottom, which gives us 8/11. 8/11 is not the same answer we got previously. We had 5/7, and 8/11 is actually bigger than 5/7. This is not surprising if you go back to the dartboard analogy. Consider throwing one round of 2 out of 3, and not just one, but 2 rounds of 3 out of 4. Well, then we've done a little bit better than we did last time, and we expect our overall score to be a little bit better. On the flip side, if we only have one round of 3 out of 4, but we threw 2 rounds at 2 out of 3 for a total of 4 out of 6, and then we calculate a mediant in this scenario, we have a total of 4 plus 3 hits out of 6 plus 4 attempts. And so that's 7 out of 10, which is even less than 5/7. Now, I've been quickly telling you which fractions are bigger and smaller than which other ones, and just in case there's any doubt, I'm going to put the decimal equivalents of these up on the screen just so you can see that they're in the right order. There they are. So like I said, when we calculate the mediant of two fractions, we're not calculating the usual average. However, we are taking a weighted average of the two fractions. If you're not sure how a weighted average works, let me just recap this quickly. If you have two numbers, a and b, then the regular average of a and b is what? You add up a and b and you divide by 2 because we've added up a total of 2 numbers. Now, a weighted average could be, for example, 3 times a plus 2 times b, where 3 and 2 are the weights that we've attached to a and b. We've decided a gets a weight of 3 and b gets a weight of 2, so a counts a little bit more than b. And then we have to divide by the total weight, which is 5, 3 plus 2. This is going to give us an answer a little bit closer to a than the regular average because we've decided that a counts more than b does. Effectively, we've averaged the 5 numbers A, B, and B. This gives us something in between A and B, but a little bit closer to A. So, when we calculate the mediant of two fractions, we're actually finding a weighted average in which the weights are the denominators of the two fractions. So when we calculated the mediant of 2/3 and 3/4, we were giving 2/3 a weight of 3 and 3/4 a weight of 4. Our answer, 5/7, was therefore a little bit closer to 3/4 than it was to 2/3. An interesting consequence of this is that if you want the regular average, we can calculate that as a mediant as well. All we need is to make these fractions have a common denominator. So we can take 2/3 and multiply the top and bottom by 4. We can take 3/4, multiply the top and bottom by 3. Now we have on the left 8/12, and on the right we have 9/12. Now calculating the mediant of these two, we have 8 plus 9 on top, 12 plus 12 on bottom, and that is 17/24, which is the number exactly in the middle of 2/3 and 3/4. It is the usual average of the two. So I've presented this idea of the mediant on a show called Number Theory for Everyone, but I should mention that in the study and practice of number theory, we don't really use the mediant all that much. Its main application is in a context of working on something called continued fractions. And continued fractions are a wonderful topic that I hope to talk about with you in a future episode of Number Theory for Everyone. If you've enjoyed this video, please be sure to click like and subscribe, and consider supporting Tony Talks About Math on Patreon. The link is in the description. I'd like to give thanks to my patrons who are supporting this show so far. Those include Emily McDonald and Gabby Gabs. Thanks to both of you, and if you would like to join them in the closing credits of my episodes, you know what to do. Please sign up on the Patreon, and in any event, I look forward to seeing you on my next show. Thanks for watching.